Okay, we're going to have a look at the area of a triangle in this YouTube, and yeah, we've been finding the area of a triangle for years. Surely this is not higher level IB mathematics. What's going on here? Well, we know that if we take a triangle, if we go right back, I don't know how many years do we need to go back to when we first learned about this. And we learnt that. I don't know, we might have cut them up or something, I don't know, but we learnt that if you work out the area of a triangle, take its base and height, well, the area of this rectangle that encloses the triangle, that will be height times base. This is h here. H times b is the area of the rectangle, and any triangle that you draw in that rectangle is going to be half of that. It's going to be half of the base times the height. Okay, so we've been using that, and that's been no problem. But what about, I've drawn a triangle here, there's no height given on it. So what do we do? Because I've got some information, but I don't have the height. Well, all right, you might be thinking already, well, I know enough about trigonometry here. If I drop a little perpendicular down and call that h, I know enough about trigonometry to find h, given that I've got an angle here and a side length here. And this is my base here, so that's okay. Remember, your height of the triangle has to be perpendicular to the base. So there's my height. Okay, and I can work out that, I can start with a half h times b, but I don't have h. I can work it out though, because h will be equal to 5 sine 40, will it not? Given that sine 40 equals h over 5. So h equals 5 sine 40. So I'm going to get it by taking a half by 5 sine 40. Half by 5 sine 40, and that'll give me my area. So a half by, that gives me h. Half by h, which is 5 sine 40. I've still got to multiply that by the base, which is 11. Half times height times base. Now my height here is 5 sine 40, which is 5 sine 40. So we could, in fact, we could write this as a half by, and if this now, let's just say that's side A there, and that's side, that's A and that's B, and this point here is C, those angles, then this is little a, and this is little b, and this is little c. Then we could say the 5 is an A, and the 11 is a B, and the sine 40 is sine C, and we've got ourselves a little formula, haven't we? Half AB sine C, and that is in fact our formula for the area of a triangle when we do not know what the height is. Okay, well that's pretty straightforward. What about when we have an obtuse angled triangle? What do we do there, and how does that work? Well, again, if I've got my base here of say 8, and my angle here, in this case I'm going to be more general in this case. I'm going to call these, we'll go again with sort of A, B, C in that orientation. Okay. Now we're going to be talking about this angle here, theta. In which case, we want these side lengths here, which are A and B, and we're going to get them by extending. So now this is my base here. My height is perpendicular to it. So there we go there. Now over here we've got, that's side C there. Now over here we've got, well, this is 180 minus theta here. And this is my height. Now my height is equal to, so I could say that, could I not, that sine 180 minus theta is equal to opposite over hypotenuse, and therefore my height is equal to A sine 180 minus theta, but 180 minus theta is this angle here, and that's equal to, in sine language, sine as in S-I-N-E, that's the same as just sine theta. So h is equal to A sine theta. So I could say therefore my area, which is a half h times the base, if we sub this value of h in, we get a half AB sine theta with that, with h being A sine theta and B being B, and that's how we derive the formula for the area of a triangle without being given its height. We've been given two sides and the angle included in those two sides. And that's it. That's all there is to it. So we can do some questions now. That's the last exercise, exercise 8L. And that all begins on page 424. So that's Friday's work. See you then.